generator is a device that converts mechanical energy to electrical energy. The reverse conversion of electrical energy to mechanical energy is done by a motor. Motors and generators have many similarities. A generator forces electrons in the winding to flow through the external electrical circuit. It is somewhat analogous to a water pump, which creates a flow of water but does not create the water inside. The source of mechanical energy may be a reciprocating or turbine steam engine, water flowing through a turbine or a water wheel, an internal combustion engine, a wind turbine, a hand crank, compressed air, or any other source of mechanical energy.
Before the conduction machine, magnetism and electricity was discovered. Electrostatic generators used electrostatic principles. These generate very high voltages but have very low current. They operated by using moving electrically charged belts, plates, and discs to carry charge to a high potential electrode. The charge was generated using either of two mechanisms. You had one, which is electrostatic induction, or two, the triboelectric effect, where the contact between two insulators keeps them charged.
Because of their inefficiency and the difficulty of insulated machines producing very high voltages, electrostatic generators had low power ratings and were never used for generation of commercially significant quantities of electric power. The Wimshurst machine and the Van de Graaff generator are examples of these machines that have survived.
The two main parts of a generator or motor can be described in either mechanical or electrical terms. In mechanical terms, you could say it's a rotor and a stator. The rotor is the rotating part of an electrical machine. The stator is the stationary part of an electrical machine.
Electrical. Armature, the power-producing component of an electrical machine. In a generator, alternator, or dynamo, the armature winding generates the electrical current. The armature can be on either the rotor or the stator. The field is the magnetic field component of an electric machine. The electric field of the dynamo of the alternator can be provided by either electromagnets or permanent magnets mounted on either the rotor of the stator.
Because power transfer into the field circuit is much lower than that in the armature circuit, AC generators nearly always have the field winding on the rotor and the stator as the armature winds. Only a small amount of field current must be transferred to the moving rotor using slip rings. DC machines necessarily have the communicator on the rotating shaft, so the winding armature is on the rotor of the machine.
In the event of a severe, widespread power outage, where islanding of power stations has occurred, the stations may need to perform a black start to excite the fields of their largest generators in order to restore customer power service.
Electric generator or electric motor that uses field coils rather than permanent magnets will require current flow to be persistent in the field coils for the device to be able to work. If the field coils are not powered, the rotor in a generator can spin without producing any usable field electrical energy, while the rotor of a motor may not spin at all. Very large power station generators often utilize a separate, smaller generator to excite the field coils to the larger.